We're going to look at inequalities in this video. Some basic introduction to inequalities, what they are, and then we'll have a little look at how they can be represented on number lines, and then we'll take it into grids or graphs and how to display inequalities on them, and also equations as well in other videos too. So inequalities, in maths, when we have something that's equal to something else, like we've seen lots of like x equals 4, we know that x is one particular value, it takes the value of 4. But say we want to write something where we've got a range of values that we want to exist for a particular question. Then we use inequalities. So we can write things like x is less than 3 or x is greater than 4. Okay, so there's these new symbols. We'll talk about these, what these symbols kind of mean. So if we write, this is just like an introduction to what inequalities are. Then we can write x less than 4. So this is read as x is less than 4. Okay, and we write it like this. I always imagine this as the bit with the smaller end, this the bit that is less than, and the bit with the open end, the kind of open mouth, is open, it's bigger. That means it's more than or greater than. So x less than 4, we write like this, and this means that x can be any value less than 4. So here we could have x being equal to 3, that would satisfy this, x being equal to minus 1.7653, whatever, that would satisfy it, still less than 4. But x equals 4.1, couldn't have that because it's bigger than 4. Or x equals 4, I couldn't have this because this is strictly less than 4. So anything that is smaller than 4. We also have x less than or equal to a value, let's say minus 2. So this is read as x is less than or, oops, like iron or equal to minus 2. So this means, this one would mean that x can be any value less than or equal to minus 2. So the difference between these two, hopefully you can see, is this little line underneath. And that little line underneath means we can have equal to as well. So without the line underneath, it's strictly less than. So that first one, strictly less than 4. We can have anything less than 4, but we can't have 4 or anything bigger than 4. Whereas if you put this little line underneath, so let's say that second example, this is read as x is less than or equal to minus 2. That means you can have anything smaller than minus 2, so minus 7,000, minus 4. And we can also have minus 2 itself. This bit includes, there's that extra bit there, that includes that extra value. So here we can have minus 2. Here, x less than minus 2, we're not allowed minus 2. Here, less than or equal to minus 2, that includes that one extra value of minus 2. So that's the difference between the two inequalities, how they're written and what they mean. And the other two inequalities are x greater than, say, 3. So this is read as x is greater than or strictly greater than. So x must be bigger than 3, so 4, 5, 6, a million, 3.962. But I can't have 3 or anything less than 3. Whereas if I want to include a value, so x greater than or equal to, and again, let's just make a random value 1. So this is read as x x is greater than, because we've got this little line underneath, that means it can be greater than or equal to. in this case 1. So the little line underneath, if you notice these two, the second and fourth one, they have the little line underneath, and that means we're inclusive of that value, so we can have equal to as well. Whereas without that line underneath, like the first and third one, there's no line underneath the inequality sign in either case. So that is strictly less than or strictly greater than. So we can't have the value itself of 4. And they're the difference between how these things are read and what they mean. Let's have a little look at them on number lines. So underneath we'll have some examples of how we draw this on a number line. So on a number line, we have different ways of displaying strictly less than or strictly greater than, or when we've got the equal to as well. So let's look at some examples of this. And this is, we're going to write the following inequalities on a number line. So let's start with that top one we had, x less than 4, and how we write this on a number line. So x less than 4, let's get a line out to give yourself a bit of room. So get your rulers out, and then we're going to mark 0 somewhere in the middle. And you've got your rulers so you can measure this, you can be a bit more accurate than me. But I'm just going to kind of roughly estimate where these would be. In both directions. So just about right, and we'll have 1, 2, 3, etc. Doesn't matter if you don't quite get to 7. But try and make it similar. So I've only got to -6, that's fine for this one. So x less than 4, how would we write this on a number line? Well, we find the value of 4, which is here. And we're going to have an open circle at 4. So open circles like this is for the strict inequalities. So we used an open circle for this one or this one. And we use a closed circle, which you'll see in a second on the next example, when we have this or this. So open circle for the strict ones, and a closed circle we'll come on to, which is basically just a coloured in circle on the strict ones. And we want to indicate on our diagram any numbers less than 4. So we pick 4, there's our starting point, so it's an open circle because it doesn't have the equal to bit, and then we draw a straight line from our open circle in the direction of the values we want. And we put an arrow on the end of it. So there's our line. So we extend it right the way, must extend to the end of the number line as far as we can in this case. Sorry, it doesn't want to rub out. Okay, it should go up to here, the -6. And this indicates I'm allowed any value, all these values where the arrow is pointing, anything less than 4. So all these values here are less than 4. Not allowed this side of it because they're all bigger than 4. So an open circle because it's a strict inequality, and then an arrow in the direction of the values you want. Number 2, so let's have a look at x less than or equal to -2. So again, get your rulers out, get a straight line drawn. Be easier for you than me. And then again, let's get 0. Get our numbers on our scale. Again, a bit easier for you. You've got your rulers to measure it and make sure it's all equally spaced. So less than or equal to -2 this time. So we need to find -2 on our number line, just here. This time it'll be what we call a closed circle. It includes the center, it includes, because it's including that extra value because of the equal to bit within the inequality. And again, we want to draw an arrow in the direction of the values we want. So we want everything less than or equal to -2. So again, we want everything this side, this way. And again, you've got your rulers, so it should be a bit neater than mine. Extend to the end of the number line. And then an arrow to point in that direction. And that's how we indicate any values less than or equal to -2. A closed circle, because we've got the equal to bit. See the difference? This one doesn't have the equal to, open circle. This one does have the equal to, closed circle. And then 2 more. So let's do the greater than ones. So greater than, let's do greater than 3. So that's the one we looked at. So x is strictly greater than 3. Again, we're drawing this on a number line. Zero in the middle. Remember, pause the video if you need to kind of catch up or get this drawn. Something like this. Same kind of idea, even though it's greater than, so we find the value of 3. Strictly greater than 3, so we want an open circle at 3. We want all the values bigger than 3. So we point the arrow in the direction where all the arrows are bigger than 3, which is going to be this way. This side. So that would how we would indicate x bigger than 3, strictly bigger than 3, doesn't include the value of 3, hence the open circle. And then finally that last one was x greater than or equal to 1. So number 4, let's show that one. X greater than or equal to 1, so again, number line with a ruler. 0 slap bang in the middle. 1, 2, 3, 4, 5, 6. And we want x bigger than or equal to 1. So we want everything at 1. So here's 1. Because we want greater than, we want equal to. So we're including that value of 1. So closed circle. We want everything bigger than 1. So we want our arrow pointing at all the values bigger than 1, which are all this side. Right to the end of the number line, always to the end. See, I've always drawn it to the end, to the end, to the end, to the end. It should always be to the end of the number line in the direction of the values you want. Open circle for the strict inequalities, where you don't have it equal to, but when you've got it equal to that little line underneath, we can include that value, include it, we fill it in to show that we're including it. We'll have a look at another video and we'll go into slightly more complicated ones where we look at ranges of values and split inequalities, and then take it a little bit further and look at this on grids and graphs as well.